Hello folks, and welcome to the next episode in our electric drift car series. So what I had been hoping to do today was to give you guys kind of a first little teaser of some burnouts. Sadly though, that's not going to be the case for this episode. Why is that? Well, the reason is I have got a blown valve. So I don't know if you're going to be able to see that, but there's a nice big crack around the entire case of that IGBT. And this is one of the IGBT bricks from the Enova inverter. So you may remember in the last video I had said that I thought that I didn't have a current sensor working properly. And so I made two mistakes. The first is I thought, oh, it's just a dodgy current sensor. And then the second mistake was I started to push power without functioning current sensors. Bad. So we blew it, literally and figuratively. So what I have been doing then is I've been doing a lot of investigation as to why this particular problem occurred. And the reason was not down to a faulty current sensor, but was down to a very insidious little extra track that had appeared on the printed circuit board due to me having named two nets the very same, or having two nets being the same name, and they were then joined up. Now, most times that you make a mistake on a printed circuit board, it's very obvious, you know, the thing doesn't work or it's a short or something like this. But this particular mechanism basically fooled the hardware current limiter into thinking there was no current flowing through the phase wires to the motor. Disabled the hardware current limit, and then cause the DSAT detector to continuously retry. So I'll show you guys that when we get the logic board up on the bench. But yeah, this is kind of how it goes sometimes, and I suppose I'm somewhat justified in that I can say, well, it's a drift car, of course it's gonna blow up. So I blew up my electric drift car. So let's go have a look. Alright, so this is the actual IGBT brick. This is the one that failed. There is 600 amp, 600 volt part. And you'll see here, you know, I can get my nail in there. There's a pretty big crack in the casing all the way around the brick. Very nasty blast off, and I still have the ringing in my ears from that. Now, the good news is we've got some bricks that we can replace it with. These are a slightly different part, as you will see. They're the same hole configuration for mounting, but these use M8 bolts, these use M6 for the terminals. We've got slightly different terminal connections that we're going to have to work with as well, but I'll work through that. That's not a major problem. So these are a 1200 volt 450 amp part, so slightly different, but they'll definitely work enough to get us moving. Alright, so in the car itself, you'll see there where I've taken out the failed brick. Now these two are probably okay, but I'm going to replace all three parts anyway. So I'm going to go ahead, take the logic board out, and we'll get this up on the bench, and I'll show you the modification, and then we'll do a full test with the three new parts before reinstalling everything into the inverter here, and hopefully be able to go for a drive again. Alright, so on the bench here now we have our logic board turned over. I'm going to try and show you this here. I don't know how well it's going to turn out, but this little track where you see the cut that I've just made here, this track should not exist, and this is what caused all of our problems. So I've got it cut So we're going to go power up now and see if things work better. Alrighty, so with the board powered up on the bench and the minimum signals present, I've got that track cut, and I'm simulating the current sensor inputs here, just with the second channel on the power supply, set to 2.2 volts. We come over here, we'll see now that whereas we've been just getting zeros here on the currents, we're getting valid values here on our current sensor inputs. And if we crank this a bit, I'm going to say a decent bit of current flow just to simulate that. Yeah, there we go. So both current sensor inputs are now functioning properly. Alrighty, so we've been doing quite a bit of work here, and so not only did we have the original problem with the track on the back of the PCB here, but I had discovered another problem whereby this device wasn't connected either to power or ground. So we have that done now. We have the power stage kind of testing here now on the bench. I've got it remade up with the three 450 volt, 450 amp 1200 volt parts, and we have those connected to the original Innova board here back to our combi board, and they're now working. You can see they're driving away merrily, and also now if we get a desaturation event, I'm just going to disconnect one of the other transistors here and let you guys have a look. Oh, hang on, I'll do it one-handed. Take 10. There it goes. That's me disconnecting a different one. That results in all the transistors being soft shut down because we have a desat event. So what we need to do now is get the power stage re-established in the car with the new parts, and then we'll put the logic board back in and we should be able to start driving things. Alrighty, so we're back in here. We've got our new transistors installed. Mods to the logic board are done, so we should be ready to give this thing a try. I did find another problem, which was that I had the dead time between transistors set way too low. So got that fixed, and let's go for a little bit of a spin here and see how things work out. Okay, stop is out, neutral, on, dash on, inverter on. Yeah, for some reason my software in the transmission side isn't transmitting the voltage properly, so I gotta fix that. Okay, might have put an older version on there. That's not a showstopper. We'll just climb over the little chop there that I have. Alrighty folks, so we're just back here with good old Super Turkey again, and so I've been solving a couple of problems that we had recently. So you'll know that I've sorted out the power stage, and that really seems to be working well now. We had a couple of problems on the logic board, so that's all patched up also. The other problem that we experienced then is this chattering main contactor. So I looked around the circuit, didn't really see anything wrong, could only really surmise that it must have been a kind of an impulse current draw from the economizer on the kilowatt relay. So what I decided to do was put a small automotive relay in there to control the main contactor, and that solved the problem. It just banged straight in now. Alright, so that's about it. Let's go do a couple of little drives. Oh, I'm going to put some more oil into the gearbox, see if we can quiet that down. And then we'll take the car just around the block a little bit and just kind of see where things are. So stay with us. Alrighty, folks, we're back. Hopefully not going to blow up this time. So let's go do a few little drives around, see how things look. Got the laptop set up here. Got a camera here. Got a camera under the car so we can see if we're still making noise out of that subframe or diff or whatever's going on there. And yeah, so should be a good bit better this time. So let's go see what happens. So computer is set up, so power on the dash. I've still got a software problem with the battery monitor. I got to figure out what that is. I can't replicate it on the bench, so I'm going to have to have a look at the CAN packets and things like that when we get ready. So okay, inverter on. Okay, so there goes the pre-charge. Pre-charge is complete. Right, neutral. That button is out. Hit the start. That closes the contactor now. There's no more of that jumping around contactor stuff. Oh, forgot the power steering. Power steering on. Still don't have any power brakes, so then again we're not really doing much speed here, so no big deal. Power steering's working. stop that plot. Let's see if we can plot speed, because I still think we're dropping out the I gotta get a tacho on this as well. But I think we're definitely dropping out the USB, unfortunately. Let's go start plot. Okay, that's the plot of speed, so let's see if we can just back up a touch here. Yeah, it's not. Okay. I don't know, guys. Gearbox is weird. Yeah, we're maxing out on frequency. That's 100 hertz is our maximum frequency. That's interesting. Air brakes. That's what I've got here. Yeah, pretty much. Alright. Alrighty folks, so that's pretty much the update for this episode. So yeah, quite a bit went on here, blown the big IGBT in the inverter, getting new ones in there, finding the problems with the logic board, so quite a bit done, you know, quite a few niggling problems fixed up. So I'm quite happy with that. You know, we do have problems there certainly with that ANOVA gearbox. It doesn't sound very good. I think it's just down to the design of it. I don't think it's very refined. But hey, you know, no big deal. The one thing I did find there was that even at 150 hertz, so 4,500 revs, I was actually tapping out on the throttle very quickly there. So we'll need to get a bit more space. We'll need to get on a track or a straightaway or something where we can actually wind up the frequency a bit. But all that stuff will be coming after we get a cooling system fitted, because that's got to be the next stage. I have no cooling on the motor or the inverter. Admittedly, neither are making much by way of heat at the minute, but when we start leaning on them, they will do so. So yeah, not too bad. I definitely have to give myself a slap on the wrist for the few problems there with the inverter and for leaning on it too hard before I had those problems fixed. But hey, you know what? That's life. So alright, I'm gonna pretty much leave it at that, guys. As usual, thanks very much indeed for all the support. Yeah, just, you know, because sometimes it can get a bit yeah, it can kind of get a bit frustrating, this, you know, but you know, when you get a nice message of support or you get a nice comment, it kind of helps you want to make more of this kind of crap. Hell, I don't know why you guys watch this, but thank you anyway. So I will see you in the next video. Don't forget to subscribe and leave a like, and I'll be putting a link in the description to an email address where if you would like to make a PayPal donation to fund my crazy projects, that would be much appreciated. So yeah, that's it. We'll see you guys next time. Happy drifting, and don't blow up any transistors.